Okay. Good afternoon, ladies and gentlemen. Good afternoon, ladies and gentlemen. It's almost good evening. It's 6:29. My topic for this evening will be a solar power equipment. I got an inverter here. This inverter is a sine wave inverter around, how many watts is it? 600 watts, pure sine wave. Pure sine wave meaning the wave is actually a sine wave, it's alternating, it's sine wave. It's compatible with the digital circuit. And in here, the power supply of this inverter should have been a battery, but my battery is worn out, so I must have to dispose the battery. But I needed to show you that this inverter is working. So instead of powering up this inverter by using a battery, I use my, what you call this, converted ATX power supply, which comprises of 4 volts. Actually, this came from my previous vlogs. I bring out the 12 volt, the 3.3, the 5 volt, and 12 volt. So instead of using a battery to power up this inverter, I will just use the output of this ATX power supply. I will just use one of the 12 volt terminals. One of the terminals is this one here, and the ground portion is actually this portion here. Okay, so to power up this inverter here, I just needed to inject 12 volts to this inverter. But the requirement is that the input voltage should not go beyond or below 12 volts, because just in case it will go below 12 volts, okay, if it will go below 12 volts, okay, there is an alarm for this one indicating that you should stop it from operation. But since my power supply is actually a regulated power supply, there is no chance that the voltage, input voltage of this inverter will go down, because as an additional thing, I added a voltage regulator, the one used for cars. This is a 12 volt regulator. So the input to this another voltage regulator is actually this terminal here, this red terminal, and this black thing here. That's the input to the voltage regulator. So we are inputting a regulated DC voltage, and still we are regulating the one that goes to the inverter. So it's a double check already. Okay, so I'll now be connecting the input to the voltage regulator. Other than this, okay, I will be injecting plus 12 volts here, and the black terminal should be the ground coming from my ATX converted power supply. And the output of this voltage regulator goes back at the back here, the one with the black and the red here. Okay, this goes to the input of the inverter at the back. So once we inject voltage here, there is a voltage on this dedicated voltage regulator, and the output of this one will go into the input of the inverter. Okay, and that will be the one that will power up this inverter. And as you check to the output of this inverter, I place already an ammeter here, a multi-tester set to voltage AC. So when we energize the power supply, okay, the dedicated voltage regulator will be alive, and the output of this one will go to the input of the inverter, and as soon as the input of the inverter is activated, this will be alive, and of course there will be an output voltage here, which is supposed to be alternating current voltage. So for us to measure the voltage that will come out here, as soon as we power up the inverter, I place a multi-tester here set to the voltage AC measurement. Okay, so what do we do now? Okay, let's try to power up. The cord that goes to the ATX power supply is this one here, the one plugged in on the convenience outlet. So I will now try to flip on the switch. Okay, and the ATX power supply is alive because this LED lighting refers to the LED of the 12-volt output. And I have connected already the plus terminal of the dedicated voltage regulator, the one that goes to the inverter, and so with the ground. Okay, so I will now try to flip on the inverter. The inverter is alive. Okay, it got a green light. It's not a red light, because if it's a red light, the voltage we are actually injecting to it is actually less than 12 volts. The mere fact that this light here is green, meaning to say our voltage is actually greater than 12 volts. So this will not alarm. Okay, and since I place a multi-tester here, the voltage is actually 113.6 volts, alternating current. Okay, so the voltage coming out for this outlet here is actually 113.6. There are two outlets here, and the first one, I plug in an FM with the tape function receiver as a load. The input voltage to this FM radio with the tape is actually 120 volts. 120, 115. So I will now plug in this one, but the radio is not yet on. The FM radio is not yet on. Okay, we have verified that the output voltage of the inverter is 113.9. Okay. It's almost 115. So for us to know if this inverter really works, this is sine wave. So this is compatible for digital circuits, because just in case this is a square wave, if you try to plug in an electronic equipment, if it's a square wave, there will be a humming sound that will be coming out, indicating that the output of the wave of the output is not alternating current. It's alternating current, but it's a square wave. What we need for digital circuits is actually alternating the sine wave, the smooth sine wave. So I will now try to flip on this radio here. And it works, right? The radio works without any interference, meaning to say the output coming out for this inverter is actually a pure sine wave without any interference. Okay, one more time, I will try to flip in the radio. Okay, this is the cord for the radio. What it needs is actually 120 volts for it to operate. Okay, it works. It works. So as you can see, this inverter is working even though we are not using a battery, because actually inverter is supposed to be powered by battery. So during brownouts, we could use this one. But since for the meantime, like what I said, my battery was old, so even though if I charge it, it will not retain any more charge. So I just, what you call this, recycle it. But for the meantime, just to show you that this inverter works, even though with a regulated power supply from an ATX power supply from a computer, this should also work. The good thing about this, I inserted another voltage regulator between this power supply and this inverter to regulate the voltage going in, to regulate. Because we don't want that the voltage, what you call this, injected to this inverter will go to the red light. If the red light will be lighted, the injected voltage is actually below 12 volts. And supposed to be this inverter should not be working. We should shut it off, because if we don't shut it off, it will be damaged. But since the inverter is actually got a green light, meaning to say the voltage coming from the ATX power supply is actually sufficient for it not to go below 12 volts. The good thing about it, like what I said, it got a dedicated voltage regulator between the power supply and the inverter. This one. This is the heatsink. So we injected any voltage on the input of the voltage regulator, the output of the voltage regulator, this one, this small one here, goes to the input of the inverter. Okay, and since this is green light, meaning to say the output of this one is actually more than 12 volts. Okay, one more time before we will go for this evening, I will try to operate the radio.
Season begins with great deals at Albertsons, Lawns, and Pavilions. Enjoy summer savings and fire up the grill. Guy Ritchie spouts them.
It works. The tape function works. Okay? It works. Okay? So that's it. That's how we power up this inverter by using a regulated ATX power supply, and connected in between this ATX power supply and this inverter is a dedicated voltage regulator for us to maintain the voltage input on the inverter to not go beyond or below 12 volts. Okay, good evening from Los Angeles. This is Professor David J. DelosReyes.